falling into a black hole means certain, irreversible destruction. Black holes are regions where gravity crushes everything without mercy. The nearest stellar black hole sits over 1,500 light-years from Earth. The moment you cross the event horizon, escape becomes mathematically impossible. Surprisingly, you would feel nothing unusual crossing that boundary. Outside observers watch you slow to a frozen standstill. Your image turns red, dims, and eventually fades to black forever. This is gravitational redshift, predicted by Einstein over a century ago. Light from your body stretches to wavelengths no instrument can detect. To the outside universe, you hover at that edge for eternity. But from your perspective, you sail straight through without pause. Einstein's relativity creates two completely different realities for the same event. Time itself bends near a black hole's gravitational pull. 1 second near the horizon equals years for someone far away. This is not science fiction. GPS satellites correct for this every day. Without that correction, your navigation would drift by kilometers. Near a black hole, time dilation becomes extreme beyond imagination. 1 hour at the horizon could mean 1,000 years pass outside. Now the real danger begins. Tidal forces start pulling you apart. Gravity pulls your feet harder than your head by millions of newtons. This gradient in gravity is what creates the tidal force. This stretching effect has a terrifying name: spaghettification. A stellar black hole would kill you before you even reach the horizon. Its mass creates lethal tidal forces across just 10 kilometers. But a supermassive black hole is a completely different story. Sagittarius A star at our galaxy's center weighs 4 million suns. Its event horizon stretches wider than Mercury's orbit around the Sun. Crossing that enormous horizon, you would float peacefully for hours. The tidal forces at that scale are weaker than Earth's own gravity. You could check instruments, take notes, even eat a meal inside. But there is no turning back. Every path leads deeper inside. Inside the horizon, spacetime itself changes its fundamental rules. The radial direction stops being a direction in space. It becomes time itself, and just like time, it flows only one way. The singularity is no longer a place in space. It is your future. Every direction you look, every path you take, leads to the same point. Even firing your rockets outward only accelerates you toward it. Light itself is trapped, spiraling inward alongside you. Looking up, you see the entire outside universe compressed into a ring. Billions of years of cosmic evolution flash by in mere moments. Stars are born and die in the time it takes you to blink. The Andromeda collision with our Milky Way plays out in seconds. You are watching the death of the universe from the best seat that exists. Meanwhile, tidal forces grow stronger with every passing moment. The difference in gravity between head and feet doubles, then triples. Your body begins to stretch like warm glass pulled from both ends. Simultaneously, lateral tidal forces compress you from the sides. Your bones fracture before your nerves can register the pain. Atoms in your body separate as molecular bonds finally shatter. You become a stream of elementary particles falling toward the center. The singularity awaits, a point of infinite density and zero volume. Every black hole contains one, hidden behind the event horizon. General relativity predicts density reaches infinity at this point. But physicists suspect infinity means our equations have broken down. Quantum mechanics and gravity refuse to agree at this extreme. Solving this conflict is the greatest unsolved problem in physics. String theory proposes tiny vibrating strands compose all matter. Loop quantum gravity imagines spacetime itself made of discrete atoms. Neither theory has been proven. The singularity keeps its secrets. What happens to the information that made up your body? Every atom in you carries information about your entire history. Quantum mechanics demands that information can never be truly destroyed. Stephen Hawking proved black holes actually radiate energy very slowly. Pairs of particles constantly pop into existence at the horizon edge. One falls in, the other escapes, carrying energy away from the hole. This Hawking radiation means every black hole is slowly evaporating. A stellar black hole takes longer than the universe has existed to vanish. 10 to the power of 67 years. An unthinkable number. But when it finally evaporates, it releases everything in one final flash. The information paradox asks, where did your information go? Hawking initially believed it was destroyed forever, violating quantum law. He later reversed his position in one of science's most famous concessions. Modern theories suggest information is encoded on the event horizon. Like a hologram, the three-dimensional you lives on a flat surface. This holographic principle might rewrite our understanding of reality. Black holes are not destroyers. They may be nature's ultimate recorders. Every particle that ever fell in may leave its mark forever. And yet the universe outside continues as if nothing happened. Physicists now use black holes as laboratories for theories they cannot test on Earth. Gravitational wave astronomy has opened an entirely new way to observe the cosmos. The black hole gains your mass and settles back to silence. Gravitational waves carry the news of your arrival at light speed. LIGO detected waves like these for the first time in 2015. Two black holes merging released more energy than all visible stars combined. That single chirp confirmed Einstein's century-old prediction. Black holes shape galaxies, ignite star formation, and seed cosmic structure. Without them, the Milky Way itself might never have formed. They are engines of destruction and creation in equal measure. Every large galaxy harbors a supermassive one at its heart. The one in M87 was the first ever photographed, in 2019. That image required a virtual telescope the size of planet Earth. 8 radio observatories synchronized across 4 continents captured it. The raw data filled half a ton of hard drives shipped by airplane. And there it was, the shadow of the event horizon, exactly as predicted. Proof that these objects match Einstein's math with astonishing precision. In 2022, the same team revealed Sagittarius A*, our own galaxy's black hole. Future space-based detectors will hear black holes merging across the entire observable universe. The largest black holes hold the mass of 50 billion suns. Ton 618 is so massive, our entire solar system fits inside its horizon. Falling into that monster, you would cross the horizon in perfect peace. You could survive inside for days before the end found you. But the singularity would find you eventually, as it finds everything. In the final fraction of a second, spaghettification becomes absolute. Every atom, every quark, pulled into a single dimensionless point. And in that moment, physics as we know it simply stops working. What lies beyond, no equation can predict and no experiment can test. Perhaps a new universe. Perhaps nothing at all. Perhaps something unimaginable. So if you ever found yourself falling into one, remember this. You would witness the most extreme physics the universe can produce. Time would warp, space would bend, and your atoms would join the singularity. But your information might survive, encoded on the horizon for eternity. Black holes remind us the universe is far stranger than we imagined. Every equation we write about them reveals how much we still do not understand. We have only scratched the surface of what they can teach us. And every new discovery